Okay, so we have went through factoring, we've went through using a technique of completing the square, and we found that completing the square is more powerful than factoring. Maybe not easier. Factoring is usually easier, but completing the square is more powerful in that if it doesn't factor, you can always complete the square. And you can complete the square on things that factor or things that don't factor. And someone down, got tired of completing the square and came up with that quadratic formula, as we stated. And the quadratic formula is something we want to memorize, and I'm going to write it here. Negative b plus or minus square root b squared minus 4ac all over 2a. We're going to talk about how to use the quadratic formula to help us find other types of forms of equations and parts of graphs. Okay. I'm going to save you the time here. If you try to factor this problem, it doesn't factor. There's no factored form. But we could still see if it has x-intercepts. And to see if it has x-intercepts, we take our equation and substitute in 0 for y. And in solving this, well, we could use the quadratic formula. And so here we have a is 2, b is negative 3, and c is 2. So I'm going to substitute those in to this formula. Notice as I plug in the numbers or substitute those numbers in for the variables, I tend to place them in parentheses. It's not something you always have to do, but it's something that will, it's a precautionary thing something that will help you not make small errors, okay? Especially when you're plugging in a negative. Like in the first, when I plugged in b here, the negative b, there's a negative that comes with the formula, but then b is also negative, so I got a double negative here. And so just using the parentheses can help you. After I plug it in, I usually multiply everything that I can. So the negative times the negative 3, the 2 times the 2, the negative 3 squared. I go through the problem and just get through all the multiplications. We end up with 3 plus or minus square root of 9 minus 16 all over 4. Can I take the square root of 9 and the square root of 16? No. You have to subtract before you try to take the square root. And 9 minus 16 is negative 7. And there is our answer, kind of, because we notice there's a negative underneath the square root, which should trigger what? Imaginary number, the I, okay? And so never leave the square root negative. We're going to change that to 3 plus or minus I square root 7 over 4. So do we have any x-intercepts? No. Well, x-intercepts are only real numbers. So if you have an imaginary answer here, no x-intercepts. But we could say, what would 3 plus I root 7 over 4 or 3 minus I root 7 over 4 represent or be called? We call these zeros. We call these roots. Okay. Okay. So what's our what's our y-intercept? Okay, if I plug in 0 for x in this equation, I'm going to get y equals 2. So 0, 2. And almost feels like we're getting stuck here, but let me remind you of something here. If we go back and look at some prior problems we've done, remember so what is this? All right, it's freezing on me. Give me a second. Okay, number 22. When we first started getting square roots, and for our for our x-intercepts, and I was pointing out a pattern to you, showing you that the like in number 22, we got -4 plus or minus square root 5. That -4 turned out to be our line of symmetry, or axis of symmetry, the middle of the graph. And then the plus or minus square root of 5 was how far you moved to the left and to the right of that middle. Okay. Well, when we were solving the quadratic formula, before we got to our last step, we had the negative b over 2a plus or minus, and then the square root part. And it's the same idea that negative b over 2a is the middle, or the axis of symmetry. And then the square root part is how far from the middle that our x-intercepts are landing. So we can use this idea to find our axis of symmetry. And our axis of symmetry can help us find our vertex. And that can help us find our vertex form. So, so that is the next step. So again, from our quadratic formula, this part right here, the negative b over 2a, I highlighted, is actually the middle, or the axis of symmetry of our graph. And so x equals negative b over 2a, which comes out to be what? We end up with x equals 3 over 4. And you could see it right here. Okay, when we solve for x, if you take out the square root part, you have your middle, you have your axis of symmetry. Okay? And so when you have a parabola, the axis of symmetry always goes through the vertex. And so the axis of symmetry and the vertex share the same x value. So we know the x value of our vertex is 3/4. We just need the y value. If you know an x value, you can always find a y value by plugging it into the function and solving for it. And so that's what we're going to do next. I'm going to go back to standard form. I'm going to plug in x equals 3/4 and see what y equals. We have a little work to do with fractions. Follow order of operations. Do the exponents first in this problem. So 3/4 squared is going to be 9 over 16. Then multiplication. 3 times 3/4 is 9/4. This is 2 over 1 times 9 over 16. We can reduce that to 9 over 8. And I want to get a common denominator, so I'm going to multiply the second fraction by 2 to get a denominator of 8. I'm going to multiply the 2 by 4 over 4 to get 8 over 4. Sorry, 8. No, I meant 8 over 8, huh? That's what I'm going to need. So 16 over 8. And then add and subtract the numerators, and we end up with what? So 9 minus 18 is negative 9. Negative 9 plus 16 is 7. So 7/8. So we have the other part of our vertex. So then, write your vertex form. What would it be? Y equals 2. Where's the 2 coming from? That's A. And then X, keep going, minus 3/4 squared, 7/8. And normally I would make you find more pieces, but it's a lot of work just to get there. So I don't, as I said, I don't need you to do the rest of this. And the graph is, you don't have to do that either. But I do want you to get the x-intercept, y-intercept, vertex, axis of symmetry, vertex form. Okay. Let's try this again. But let's, for time's sake, I don't know if I think I might run out of time. I want to do 32 and 33, but let's do 33 together now. I want you to see what happens on this one. So try to factor, it doesn't factor. There's no factored form here. So then you go after the x-intercepts. So you plug in 0 for y. And you're going to use that quadratic formula. Practice memorizing that. The sooner you memorize it, the better it is for you. Okay, I'm going to pause here. I'm going to keep working on it, but I'm going to freeze the screen so you can't see what I'm doing because I want you to work ahead of me. Okay? I want you to try it on your own, plug it into the quadratic formula, and see what you can get. Double negative mixed positive. On this one, you should get 1/2 and negative 2/3. Here's how. Okay, you carefully plug it in, the quadratic formula, and underneath the square root, you end up with 1 plus 48, which gives you 49, and we know the square root of 49. So the square root goes away. And whenever the square root goes away, That means, first of all, it's going to factor. There's no square roots. So I could have factored this. And you're going to have to split it up. One with the plus sign, one with the minus sign, and it gives you your two answers. So we got 1/2 0 and negative 2/3 0. Anybody tell me what the axis of symmetry is? Do you see it in here? What's the axis of symmetry? Negative b over 2a. Here it is, negative 1/12. That's your axis of symmetry. That's the middle of the graph. So that's the second thing we find. And you could plug it into the formula negative b over 2a. Sorry, that's not the axis of symmetry. Axis of symmetry should be a point. Huh? The number's right, but the form is wrong. How did we used to find the axis of symmetry before when we had the x-intercepts? You remember what we did? If you knew it was 1/2 and negative 2/3, what would you do with those to get the center? Add them and divide by 2. And if you do that, if you add them and divide by 2, you'll still get the negative 1/12. So I'm giving you another option. So you can still add and divide by 2, or now you can use negative b over 2a, which is a quicker route, right, to getting that. We still don't have the full vertex, though. This is negative 1/12. We got to find the other piece. So let's plug negative 1/12 into this equation. By the way, before I do, what would factored form be? Y equals a times x. If 1/2 is a x-intercept, x minus 1/2. And what's the other one? X plus 2/3. So there's our factored form. So whenever you get x-intercepts that don't have square roots, you can do this. All right, back to the vertex. Work it out. I'm going to again pause it. You get it. Try to work ahead of me, okay? I'm getting negative 49 over 24. Anybody else get that? Did I make a mistake? Yeah, you got that. Okay. I just went too fast. Sorry, I'm rushing towards the end of the period. All right, that's as far as I'm going to go. That's where you would stop on this problem too. So we've done 2 problems together. You have 4 more to try on your own, like this. Okay. I'll pause here and.